So we all know relational databases provides ACID guarantees, but what is I in ACID? I in ACID stands for isolation. Now, what do we mean when we say that, hey, database gives you isolation? Now, just to clear things up, isolation, like when database says, hey, we provide isolation. So it's isolation between transactions. So when there are two transactions running parallelly on my database, what kind of transparency one has over other? That's isolation. The way database gives you tools to tune that is called isolation levels, which you can change. You would have already heard of it, but this is exactly where it fits into the scheme of things. Now, isolation level dictates how much one transaction knows about other when given both of them are executing at the same time. Now, what we'll do in this one is we'll go through each one of them and practically see what's happening behind the scenes. We'll take hands-on examples. We'll write actual queries to see how this affects how much of transparency we have one over other, right? So there are four SQL 1992 standard isolation levels possible. First, we'll start with repeatable reads. So the four are repeatable reads. First is repeatable read, second is read committed, next is read uncommitted, and fourth is serializable, right? We'll take a look at each one of them with examples to understand what they are. So first, let's start with repeatable reads. Now, repeatable reads is really interesting. So what it does is it talks about giving you consistent reads within same transaction. Let me take an example writing actual queries to help you understand on what that is all about. So here what I have done is I have created a very simple database in which if I show you, so select start from users. I've created a simple users table. Let's do a describe users. You see there are just two fields. First is integer, which is primary key, and name. So it's the ID of the user and the name of the user. What we'll do is we'll quickly insert just one row in this table, right? So now if I do select start from users, I would see one row, ID 1, name A. Now this is where we would play our games with. Now I have two sessions logged in, left and right. Left will be transaction 1 always, right will be transaction 2. Now here, first let's start with understanding repeatable read. So first what we'll do is we'll check what the transaction isolation level, what the current transaction isolation level is. The current transaction isolation level is repeatable read, which is what we need. So the command that we fire to get the current isolation level in MySQL, by the way, FI, I'm using MySQL, right? So this is all specific to MySQL, but the concept of isolation level spans to all relational databases out there. But the demo I'm running on MySQL. So go through documentation of the database that you're using in case you'd want to go deeper into what kind of guarantees your database provides. Now select @transaction underscore isolation gives me the current isolation level of my transaction. So let me run it on other session as well. And both session we see it's repeatable read, right? Now let's see what repeatable read, like what it does. Now here, what it says is that when I am actually reading the data, like let's say I have one row. We have inserted one row in the table. So we have inserted user ID 1, name is A. Now here, let's say I start two transactions. So I start transaction, let me set auto commit to 0. Now FYI, what auto commit does is in case you are not running in a transaction, auto commit automatically commits every single line as and when it happens, right? But I'm explicitly setting auto commit to 0 in both the terminals in order to ensure that there is no auto commit magic happening, right? We'll write simple queries to understand what's happening behind the scenes. So here what I'll do, I'll start my transaction 1 and I'll start my transaction 2. I'll start my transaction 2. So in both the places, both sessions, transaction 1 has initiated, transaction 2 has initiated. Now what we'll do is we'll read a row in transaction 1. So I've read a row in transaction 1. So select start from users where ID equal to 1, I got A. This row is read in transaction 1. Now in transaction 2, I would read the same row. So both have read the rows, both got A, which makes sense. Now what next? Let's say my transaction 1 updates the row. Now in my transaction 1, I'm firing an update. So my transaction 1 fired an update. It is yet to be committed. So now what would happen is if I read the row in transaction 1, what would we get? if I read the row in transaction 1, I would get the updated value because it is within this transaction, you got the updated value. You read A, you updated. Now you are reading that row again, you'll get the updated row. But what happens when you read the same row in transaction 2? Given that my transaction 1 has neither committed nor aborted, what would my transaction 2 see when it is trying to read the same row? It sees the old row, which means that it does not matter if transaction 1 has made any changes. Unless those changes are actually committed, the transaction T2 will not see. And it makes sense. It's basic sense right now, right? But things become interesting. What makes repeatable read interesting? Now with repeatable read, what happens is, now let's say my transaction T1 commits. Transaction T1 made the update, transaction T1 committed. Now if I read the row, I would get A underscore T1. Now comes the interesting part. What would happen? Transaction T1 committed. Now the actual value of row is A underscore T1. Transaction T2 read the value, it got A. Transaction T1 committed. Now if after transaction 1 has committed, if I read the row in transaction T2, what should we get? If we fire this, we still get A. This is the beauty of repeatable reads, that you can repeat your reads within the transaction and it would give you a consistent view of it. Because now what has happened is, if this would not have been there, now if you do this, now if it starts seeing the new value, it seems wrong. So repeatable read gives you these guarantees. The first read that you do, whatever value you see, you would continue to see that same value no matter how many other transactions make any changes to that value. So it is basically opaque to what has been done elsewhere in the system. This is the concept of repeatable reads. Right? Now I hope you understand what repeatable reads are. Now no matter how many times my transaction T2 reads the same value, it would always see this same thing. But if my transaction T2 commits, transaction T2 never changed anything in this row. If it committed, and now if I start another transaction and read it, you get the fresh value. So you see how the reads are repeatable and consistent within a transaction, right? So this is all about repeatable reads. So now let's talk about the other transaction isolation level, which is read committed. In read committed, what happens is, when your transaction is reading the value, it would always read the latest committed value, which means that when my transaction is running, it is possible for my transaction to read two different values. For example, my first transaction was running, it read a particular value. While it is rereading the same value again, if in between this some other transaction committed, the value that it would read would be the new one. Let me show you an example and see what's happening in this case. So here what I'll do is we'll just set the isolation level to read committed. Here you see set session transaction isolation level read committed in both cases. I'll just quickly do a select and confirm that it is indeed read committed. Right? In both cases it is read committed. Now what we'll do is we'll start a transaction. I'll start a transaction T1. I'll start a transaction T2. Now my transaction 1, let me read this value. In my transaction 1, I read the value, I got A. Right? So transaction 1 read the value, it got A. Now let's say in my transaction T2, I fire an update. I update the value of that row to A underscore T2. The value got updated. And as soon as value got updated, if I read the value in my transaction T2, I would get A underscore T2, which makes sense. Now let's say my transaction T2 commits. Now when my transaction T2 committed, transaction T1 is still running. It has not yet committed. But when I read the value, the committed value is A underscore T2. So now if I read the value in my transaction T1, which is still running, now what would happen? When my transaction T1 is still running, in case of repeatable reads, it got that consistent view. But if I fire this now, it gets inconsistent view. This is the difference between repeatable read and read committed. In read committed, what happened is, In read committed, it read the committed value. Even if some other transaction wrote that, whenever my transaction is reading the value, it is always reading the committed value. So this is where you clearly see that within this same transaction, I have not terminated a transaction at all. I fired two reads and I'm seeing two different values over here. This is a problem. Why? Because with read committed, you get a little better throughput, but the problem that seems is that your reads that you are doing are now inconsistent. The next isolation level that I would want to talk about, I'd like to talk about, is read uncommitted. So it is much more lenient than read committed. Read committed, what happened is, as when I read, I always read the committed value, which means that when other transaction committed the value, now I'm rereading it, I would always read the committed value, even though I'm already running a transaction. Now what read uncommitted does is that if my other transaction has made any changes to that particular row, even if it has not committed, I would see the uncommitted changes as well. This is called as a dirty read problem. Let's take a look at what happens when you are let's take a look at this problem in action. So what I'll do is I'll set my transaction isolation level to read uncommitted, right? Which means it is okay for me to read the uncommitted value. In both the cases, I would do that same thing in both the sessions. If I just counter validate my isolation level, I see read uncommitted, I see read uncommitted. Now I'll start my transactions in both the places. Transaction T1 started, transaction T1 started, or T2 started, right? Now what we'll do is my transaction T1 selects the row from my database. It got A, row ID 1, name A. Right? Now my transaction T2 is actually updating the row to A underscore T2. Transaction T2 is running, transaction T1 is running, transaction T2 has not yet committed anything. But because my transaction isolation level is read uncommitted, if I read, I get uncommitted value. So what we are getting over here is we are getting not only the problem with the random, read committed side of things, where it was anyway just reading the committed value, here we are reading even uncommitted value. So because now if let's say I make a read again and then if I'm doing some processing on it, I'm processing on value A underscore T2, which might be wrong because it is very much possible for my transaction T2, which has made some changes, to roll back. Because if my transaction T2 rolls back, I have done processing on the data which is rolled back by other transaction due to some reasons. So this is a problem, but it's okay. It gives you little higher throughput, not significantly higher, but it gives you little higher throughput. So in order for you, it's okay for you to drop the correctness of data in some cases, but you need better throughput, you may go for this. But this is read uncommitted, that you are reading even the uncommitted data over here of other transaction. So it is possible that the other transaction either commits or rolls back. In either case, you have processed on the uncommitted data by the other transaction, right? This is read uncommitted isolation level. And here we see the problem of dirty reads, right? Now the final isolation level that I'd like to talk about is serializable. So what serializable does is it's the strictest form of isolation level, typically the slowest one as well. So what it says, it enforces the serializability. What I mean is every read that you do is a locking read. So when I read a particular row in a transaction, other transactions are not even allowed to read that particular thing. So it just blocks everything. That unless one has done processing it completely, then only other transaction would move forward. This is very strict serializability that it enforces, and you can very clearly see how it would slow things down. And it does, to be honest, it does slow things down, right? So let's take an example to understand what this is all about. So here what we'll do, I'll just commit and abort everything that I have so that all the changes are flushed out. I'll revert my value to A and my bad, and I'll do commit. Okay, So let me set my isolation level to serializable in both cases, right? In both cases it is serializable. You can quickly check if my isolation level is serializable. Oh, I just set it again, my bad. I wanted to do copy paste. Isolation level serializable, isolation level serializable. Okay, at both places it is serializable. Now what we'll do, like always, we'll start a transaction. Transaction 1 started, transaction T2 started, transaction T1 started. Both transactions started. Now what we'll do is transaction T1 updates the row, right? Update user, set name a underscore T1 where ID equal to 1. It fired an update, right? Now when it fired the update, when my transaction T2 is trying to read that row, what would happen? It waits. It is strict serialization. So unless my transaction T1 commits or rolls back, transaction T2 would not even move forward. The select statement would not even return anything. As soon as I do commit, either commit or roll back, you'd see the transaction T2 moving forward and reading the committed value. In case I would have rolled back the transaction T1, it would have read the old value. Here you see very strict serialization in place, that you are blocking out every single thing that is out there. That when I'm updating something, when I'm reading something, everyone else is not even allowed to process or move forward along that. But just a warning, it depends on the storage engine of the database that you are using. Some minor hiccups, or not really hiccup, but some minor customizations, some minor basic behavioral changes you can observe. But this is a big picture on how the 4 isolation level determines how reads and writes happen in your system, right? And I hope this cleared out isolation level once and for all for you folks, right? So whichever database you are using, see the isolation level that are there and just play around with this. Just one row, I just inserted one row, one table, one basic schema, and I just changed it and understand what is happening behind the scenes, right? I would highly recommend you to do that. And I really hope this just solves it once and for all, because this is one of the most commonly asked things, that, hey, what are isolation levels, how it actually affects, what is difference between locking and isolation. Now you understand what I of acid is. This is what I of acid is. How your transactions, like what kind of transparency that your transactions offer you depends on the isolation level of your transaction, right? So I hope you found it interesting. I hope you found it amusing. It was really fun for me to basically compile this very quick demo. A lot more videos on this database engineering topic will be coming out, especially mostly members only video. And again, it was fun for me to record this. I hope it was amusing, as equally amusing for you folks as well. Once again, thank you so much for watching. I'll see you in the next one. Thanks a ton.